All right, AP Stat class. If you are viewing this, that means you have successfully gotten to my video on section 12.1, which is inference for a population proportion. We are hypothesis testing a proportion, a sample proportion against a population proportion. And since it's very similar to what we've done before, I figured that we would just do it this way, and then in class we can kind of go over examples more than me just lecturing during class and having a little time for practice. So we're starting with sample proportions, and the notation here is very important. You have p hat. That's your sample proportion, which is the number of successes over the total number of observations. Regular old p is going to be our population proportion rather than our sample proportion. And then, of course, we have our p-value when we do a hypothesis test. So there's a lot of p's here. Just try to keep them all straight. Again, we have p, here's my pen, p is going to be our population proportion, and p hat is our sample. So this is your population proportion. Don't worry, I don't have to write too much. I did most of it on the computer already, because this takes a while. Okay, so that's for your population, p hat for your sample. So when we're dealing with inference for population proportion or hypothesis testing, of course we have conditions. Okay, I changed my slide a little bit so it's a little neater. So we have our conditions for inference. Always, always, always simple random sample or an experiment. Randomization is one of the most important pieces in any hypothesis test. Your standard deviation. I really hope this looks familiar to some of you. Back when we did proportions in chapter 9, we did this formula, or we used this formula, I should say, for standard deviation. If you don't believe me, I believe it's section 9 too in your textbook or your notes. So this is our standard deviation for a proportion. We take our population proportion, p, times 1 minus p, divided by n, and we take the square root. That's our standard deviation. As long as our population is at least 10 times as large as the sample, which means that this part right here is our condition. The population being 10 times as large as the sample. For the sample means problems, we write that too, but it's really important when we have a proportion because that's where our standard deviation formula comes from. Okay? And then, of course, to check that it's normal, so we always have random, normal, and then our population 10 times the sample size. To check that it's normal, look at what we're checking. It's not n is greater than or equal to 30. It's n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. We've done this before. That allows us to use our normal curve or our z-score charts. They're back and better than ever. You get to use z-scores, not a t-distribution for these problems. Okay? So whenever we're dealing with population proportions, simple random sample, population 10 times the sample size, and then we have to check that it's normal by checking n times p. We're using our population proportion here, not our sample proportion. That is something I find can be a little tricky. And again, we're setting this all up so that we can actually use z-scores. Okay, so we're taking our sample proportion minus our population proportion divided by my standard deviation. So it's the same formula we always use. We always take our statistic minus our parameter over our standard deviation of the population. So we got statistic, parameter, standard deviation of the population. Anytime we're looking for a test statistic, this is the basic formula. It is located on your formula sheet. But we're back to z. So we can draw normal curves here. We don't have to worry about degrees of freedom. We're going to our z-score charts. And honestly, we've done these types of problems before in Chapter 9, but now we're actually doing a complete hypothesis test, which is again why I thought it would be easier for me to give you the notes this way rather than in class, since most of this is review. Okay, so again, this follows our normal curve with a mean of 0 and a standard deviation of 1. That's what a z-score is. Remember, a z-score is how many standard deviations away from the mean your value is. Okay, so we're using z-scores. Again, statistic, parameter, standard deviation of the statistic. So we're going right to an example. And basically what we're going to do is work through this example together. You can pause or go back as much as you need to. And then what I'm going to do is leave you an example to work with for class on Thursday. So kind of a homework problem also to make sure that we're all going through these notes. Because I'm not going to go through this in class on Thursday. I'll answer questions and then we're going to kind of move on with some other things in regards to these population proportions. So for this example, we have an experiment on the side effects of pain relievers assigned arthritis patients to one of several over-the-counter pain medications. Sorry, I read that pretty poorly. Taking a simple random sample of 440 patients who took the pain reliever, 23 suffered some, quote, adverse symptoms. Does the experiment provide strong evidence that fewer than 10% of patients who take this medication have adverse symptoms? So the thing that I find is the most important is at the very beginning to distinguish the difference between p hat and p, your sample proportion p hat and your population proportion p. So look at the problem right now and see if you can figure out which is which. Do you have it? Okay. Well, if you don't, I'll give you a hint. Our population proportion is going to be the last thing mentioned. So in this case, our population proportion is that 10%. That's what we're testing our hypothesis against. We want to find if 10% or fewer people have these adverse symptoms. So this 10% is P. P is 10%. Population proportion is 10%. Oh, it's really hard to write with. Okay. And then P hat, which I always write down, is going to be my 23 out of 440. I'm not using P hat in any of my conditions. I'm using my population proportion. I'm not using P hat for my population standard deviation. I'm using my population proportion. This is my test statistic. That's the only place it appears, right here, and it will appear when I go to find my z-score, which the formula for that, hopefully you wrote down. So I have p hat. If you simplify this, it's about 5%. 0.0523, I believe. Okay, so we have these two things. So again, the question is, if we got this sample result, does that give us evidence that fewer than 10% of patients who take this medication have adverse symptoms? Okay, so think. We're going to do a hypothesis test. We're starting with our null and alternative hypothesis. You should know what those are. There they are right there. But look at our notation. We're using p now. We're talking about proportions. We're not using mean. There's no mu. It's p. So as we continue with our hypothesis test, it's the same format, but we're actually changing our notation somewhat each time and our conditions somewhat each time. Okay? Now our conditions here, remember, simple random sample, that's stated in the problem. Look at what I'm checking. This is p, this is not p hat. It's n times p is greater than or equal to 10. N times 1 minus p is greater than or equal to 10. And then our population of all patients is greater than 10 times the sample size. Okay? And you don't have to multiply that out, but you can if you want. So we have our null and alternative, and p here, which I should have written down, but I didn't. P, my population proportion, would be the population or the percent of patients who take this medication that have adverse symptoms. That's what we're testing. Okay, I just wanted to make that clear. Okay, so if I wanted to draw a normal curve, I could, and this would be P, which isn't quite centered, but this would be my 0.10, and this would be my 5%. My standard deviation, you have the formula for that. It's the square root of P times 1 minus P over N. And we're using our population proportion in that formula. So when I'm looking for my z-score, what I'm going to do is I'm going to figure out the probability by using z-scores. Okay? And my calculation for that is right here. So I'm taking what's the probability I get this sample proportion if my true population proportion is 10%. And again, look at your standard deviation formula. You're using P, not p-hat. I get a z-score of negative 3.34, which we know means our probability is approximately 0, because I'm looking from there, that negative to negative infinity. Okay, you can use your calculator. It's just a z-score, normal CDF. We know how to do that. And then, of course, we also know what this means. Our p-value is less than 0.05, so we reject our null. We have evidence that fewer than 10% of all patients have adverse symptoms on this medication, which is a good thing. Now, there is a hyperlink here. Hopefully it works. This should provide you with calculator instructions to do the one proportion z-test if you want to. The one thing I will tell you with the calculator is when you enter your data, you're going to enter what P is, your population proportion. When you go to enter your sample proportion, it has to be X over N. X is the number of successes. It has to be a whole number. And then N is the total number of observations. I can definitely help with any calculator issues in class on Thursday. But that's a common mistake people make. They try to enter X as a decimal, and you can't. Hopefully we have it. But I'd like you to try tonight on your own. Is the following problem here, and I know you can read it. We're going to discuss it in class on Thursday, and then in class on Thursday we're going to be moving on to other things. Hopefully this was helpful for you. If you have any questions, bring them to class on Thursday. This is something I won't do all the time, but I do think for certain topics it lets us practice more in class rather than worry about taking so many notes in class. And it also allows me to see what you need help with before class has even started. So thank you for listening. If you have any questions, let me know, and I will see you tomorrow.